So thank you for giving me an opportunity to present my solution for universal safety. My name is Kedar Bhumkar. I'm a technical architect working on Salesforce. So let's start with the core business requirement for universal safety. The basic requirement, uh, the core business rather for universal safety is safety and security systems, which they provide to different customers. And they are based in US and Canada, and they have grown via acquisition. That's their main core business. The major needs surround around huge growth that they expect, and they also need better integration within their systems. They also have process automation needs, which are pretty fractured at this moment of time. Key assumptions I'm making is REST API is used everywhere where it is not clearly specified, and a PDF files which are used by the system specialist, they have some record context, and there are certain more specific assumptions we'll see in the business scenarios. Some of the risks I've identified include tight deadlines, as they have a tight schedule, and this can be mitigated using an MVP approach. They have limited integration environments, which can be mitigated using mocks and stubs integration. Procurement is a risk because I'm proposing lots of app exchange packages, so we need to start that process early. Dependency on multiple teams can be mitigated by having a proper strategy around scrums and delegating standards that they need to follow. Plus, there is a delivery risk because of the use of a mobile hybrid app, which may take time to get into the stores. So again, this process needs to start early. As far as the org strategy is concerned, I propose to use a single org strategy, as I see like most of the needs can be done through process harmonization, any changes which are around US and Canada, or they could be managed using record types, feature flags, dynamic LWC pages wherever it is needed, and dynamic lightning pages. I did not see any regulation compliance needs which would hamper the org strategy. Those needs can be assumed to be within the ERP itself, and ERPs are separate. Similarly, data volumes are something that can be managed within a single org instance. I'm also using multi-language through translation workbench, visual force templates, and labels. Next, the licenses. As far as the internal users are concerned, system specialist, I'm proposing to give them sales and service license because of the need to access opportunity and work order. Similarly, for support reps, sales and service license because of the need to access leads as well as omni-channel routing. The office, regional, and HQ managers, they get the sales license as they do not need insights on the service use cases. As far as the external users are concerned, we have contractors. I'm giving them the partner license because they need access to the code within my solution. The primary customer contacts get the customer community plus license primarily because they have a need to be a dedicated admin as well as they need to access case. And the secondary customer contacts, they get customer community because of the need to access case, just case. The role hierarchy is pretty standard and straightforward. At the bottom, we have system specialists who get the office-based roles. There are 150 such roles, and they report to the office managers, which are office-based. And they also get office-based roles, and they roll up to the regional manager, HQ manager, right up to the CEO. Support reps are kept in a separate hierarchy, and those are region-based. There are 3 regions, 2 regions, and 3 departments within that. And they roll up to the support managers, which in turn report to the CEO. There are no roles assigned to the external users because there is no such need for that. So coming to my system landscape, at the center, we have the Salesforce instance on which we'll build this application. My domain will be enabled, and Sales and Service Cloud will be the core products on which we'll build this application. I propose to use some important features of the platform, including digital engagement for uh, the request that would come from the customers, Service Cloud voice, as the customers would call in for their issues, omni-channel routing, which is needed for leads, the initial leads, as well as for cases, approval flows, as they are needed as part of the initial process. I also propose to use app exchange apps like Conga and DocuSign for document generation and e-sign. Similarly, SMS Magic is used for sending the SMS, and X Files Pro for document management. I plan to use this as they would reduce the time to market and our established products. I also have a ESB MuleSoft in the mix. The ESB's purpose is to do service orchestration, API management, queuing, and retry logic, and be the basic uh, node through which interfaces would be built between Salesforce and these external systems. The ESB will be secured with Salesforce using HTTPS two-way SSL and JOT token flow. Comet T would be used for streaming use cases. At the bottom, we have the CRM system, which will get retired. The leads, schedules, and orders, which are primarily present here, will be injected back into Salesforce using an ETL tool like Informatica, which would leverage bulk API 2.0. The ETL tool will be interfaced with Salesforce using bulk API 2.0, as I said, and also the OAuth user agent flow, as Informatica only supports that flow. The monitoring systems will interface with MuleSoft using REST API, as well as the ERPs. The ERPs will have certain functions like support and sales and installation, which would be partially migrated to Salesforce. As far as the enterprise data warehouse is concerned, we have certain LDBs in place, which we'll go through, and that data needs to be backed out or archived inside EDW. And that will be done through ETL by doing it in a nightly basis or on a regular cadence. The information present in EDW would be exposed back to Salesforce using Salesforce Connect for data protocol. I also have TCRM in the mixed Tableau CRM, as the reporting needs to be done on the basis of data within Salesforce as well as enterprise data warehouse. So connectors for TCRM would be used to build data sets and dashboards and given access to the user. For file-based use cases, the computation exceeds the demand. Hence, I'm proposing AWS S3 storage right from the beginning, and that would be the primary storage, which would be interfaced using X-Files Pro. On the left-hand side, we have an Active Directory already present. So I'm proposing to use ADFS on top of it for SAML use cases. And ADFS will also be used for the SSO needs with the ERP. As far as the external access is concerned, there's an existing public website on which we'll have web to lead form that will be used for creating the initial applications. The Salesforce mobile is proposed for the system specialist as they are internal users. As far as the external users like customers are concerned, they will get access through a hybrid mobile app, as there are use cases like geolocation, which cannot be done using as there are certain use cases. Basically the hybrid mobile app, because we are having like a customer facing application, so that's why it's a hybrid mobile app, and we'll basically use OAuth user agent flow for this. There is also a need for the customers to log in via Facebook, Twitter, and LinkedIn. So for that, OAuth providers would be enabled, and OIDC flow would be used for this. The contractors would access Salesforce using the partner community directly, as they are using the codes. So with this, let's move to the data model. So I'm using the following legend. This symbol is used for lookup. The dash symbol is for master detail. And I'm using color codes. The green ones are basically either the custom objects or app exchange packages. The violet one is an external object, and rest are all standard objects. On the left-hand side, OWD is defined private by default. Right-hand side, the owner. Here, I define the LDB, whether it's an LDB object or not. And the record types are mentioned, as you can see here in a different color. So the whole process starts with leads getting created in the system, which is through web to lead, and the leads get assigned to the support reps. The support reps then do some initial questionnaires and convert these leads into a business account and a contact, and they make the system specialist as the owner of them. As part of this process, location records are also created, and the support and the system specialist is assigned to them. At the same time, a work order is created, which represents an abstraction where the system specialist can actually visit that particular location. Once this is done, the system specialist visits that location and they interact with the customer. They capture the financial information in this object, At the same time, they create an opportunity. The opportunity is associated with opportunity products, which will basically come from the products and price books. And these would typically be the systems that need to be installed. After negotiating with the customer, they will generate different quotes, which is represented by quotes and quote line items. And once the customer agrees for the quote, we will basically use DocuSign and create the DocuSign status object, which will get created and associated with the quote. Once this quote is approved by the customer, the system specialist then assign vendors to specific locations to work on. And this is represented by this lookup between a person account, which I'm using for the vendor. Sorry, the contractor here. The contractor, that's the person, against the location. The contractors then basically visit the location and do some more research. And they also create PDF files. And once they find that everything is fine, this leads into the creation of a contract. So the contract object represents a contract between the contractor and universal safety. DocuSign is used for e-signing requirements, and it is linked to the contractor here, the contract object. Once this happens, eventually an order gets created. The order is basically having order products, and it represents the same type of products, the installed systems and the needs that need to be present. And this order is then sent to the ERP. The ERP then creates an order in its own system, and that is exposed back as we have a need to see that order as an OData 4.0 object. And they have an indirect lookup relationship between the order and the ERP. The work order here is used for multiple purposes. The first one is used for the initial visits by the system specialist, and the second is used for installation by the vendor and the system specialist. So once this order is created, we'll have a work order created with this record type installation. Once the installation is complete, the system specialist creates a maintenance schedule against the location. And once the systems become online, the monitoring systems start receiving the initial calls. They will create like the assets within Salesforce, which is represented here, and those are linked to the locations. Now, case represents multiple things. One is primarily the issues that are associated with the systems. So these cases can be created by this automation system, or it could be created manually or through customers using the website. So the case is used for all these three purposes, and those cases are created against the asset. Any type of maintenance or issues would need a work order to service them. And again, the work order is used for this particular purpose. So with this, let's go to the LDV slide. So I did some quick computation in terms of what are the records for these different entities and their distribution over a 5-year period. So from this, we can make out like the assets are clearly LDVs. The monitoring systems, the assumption is 50 and 100 assets for each monitoring system over a period of time. They are definitely LDV items. The cases are on the borderline LDV. As we can see, it's around 5 million. And I propose to mitigate these things using selective various indices, skinny tables as needed. And on a long-term basis, making sure that these are archived off platform inside the enterprise data warehouse. A quick computation of the file size indicates we have around 7 terabytes of storage, which is possible. But if we go with the assumption that every file is around 300 MB, the design files of PDF, and there are some other files, then this comes out to be around 60 terabyte. So that's the reason I have proposed to use Amazon S3 and interface that using X Files Pro. Right. So let's jump to the business process requirements. So let's look into the first business process requirement, which is around sales and design. So here we have the prospective customers who make a phone call, and that gets routed to a support rep based on the availability. They submit an information request, and the support rep gets notified. So I propose to do this using omni-channel. The public website would have a web to lead form, and once submitted, it would be assigned to It will be assigned in a queue, and the queue will have the support reps assigned to them. The queue email setting would basically notify the support rep about an incoming lead. Approximately 5,000 prospective customers per month. So this is well within the web to lead limit of less than 500 per day. So we are good on here. The support reps then pre-qualify the customers using a questionnaire, and then they basically schedule a site visit for a system specialist. So here I propose to use a screen flow, and then at the end of it, the support rep would convert that particular lead to a business account and a contact, and a location and work order would be created as part of that flow. They would also change the owner to the system specialist. So system specialist, once they do the visit, they take pictures or videos. So for that, they are using a Salesforce mobile app, and they would be able to upload file size up to 100 MB. Those files will be attached uh, by X Files Pro directly to the location object, and it's actually stored in S3. Next, they will create a preliminary estimate and send a copy to the customer by email. So we'll basically expose a quick action here, and that would result into creation of an opportunity. And they can add products and also create a quote at the same time. And using the quote syncing feature, we'll create a quote line items, and we'll use Conga document generation for sending it to the customer. Capture GPS location. So for this, I propose to use an LWC.js component, which would actually store the latitude, longitude on the location object itself. Next, creation of an estimate allows the customer to access Salesforce and view the estimate and collaborate with the system specialist. So here, once the quote is saved, and after save flow would result into creation of a user record where appropriate profile would be assigned. And this would result into sending of an email to the customer. And then the customer can access the customer community and will be able to see these estimates on their chatter feed, because we don't want to expose the quote object directly to the customer. Back at the office, the system specialist creates design plans, which could be 100 MB or more in size, and they are accessible by the customer. So here I'm assuming that the system specialist attaches these files again to the location via X Files Pro, and the customer can access the location as they would have a sharing set defined. Once the design document is created, the system specialist notifies the customer. The customer can then collaborate over design requirements and then eventually sign the updated estimate. So here the collaboration piece can be handled by enabling chatter on the location object itself. And as far as the code document is concerned, we'll basically pre-tag it using DocuSign e-sign fields, and that will be sent to the customer for e-signing. That's why we have this connection between DocuSign status and code. Next, the customer provides financial data, which is recorded on their location, and that initiates an approval process with the local manager. So the financial data is recorded in a separate object, as we have some needs around visibility, which dictate this. And once this record is created, and after save flow would trigger the approval process, which will be predefined in the backend, and it would go to the manager for signing up. The entry criteria would be the install cost. Customers should use social credentials for signing in. For this, we'll basically have auth providers and OIDC flow. Auth providers will be configured within Salesforce. Now let's go into the contracting and installation needs. Contractor records are created in the appropriate ERP systems, and they should not be created or updated in Salesforce. Contractor records are sent to Salesforce daily, and contractors should be automatically provisioned, and they should be using native credentials. So for this, I propose to use my first integration approach, I01. And this is between the ERP, ESB, and Salesforce. The pattern used here is remote colon, as there is no need for any immediate action. So the basic way I propose to do it is that the ESB will have a cron job, and it will pull contractors from the ERP based on the watermark, essentially the last update or insert, and update the Salesforce records, which are contact objects here. Once this is done, I will have profile create update permissions to prevent the uh, system specialist or the support reps from directly manipulating these records. Only the integration user can create or update these records. So once these contact records are created, an after save flow would be initiated, and that would again create a user record. Profile will be assigned to it, and the email would be sent to the contractor who can then access the community. This is the automatic provisioning that would happen. The system specialist selects the contractor, at which time the design documents, estimates, collaboration space are automatically made available. So here, the system specialist would go to the location record and they will simply create a lookup between this and the contact record, which is representing the contractor, the person account, and using sharing sets on the location and the quote object, the contractor would be able to access them via the community. Quote object is needed as they need to see the estimate during the whole process. The contractor reviews the customer's document, collaborates with the system specialist and customer, and then they can revise the documents and repeat the customer approval process. So uh, for this, they would basically go to the community. Can go to the location object where they can use chatter for communication between system specialist and customer. And based on the feedback, the system specialist may create more quotes, which would be like shared with the customer. Once the design is acceptable to the contractor, acceptance is the contractor indicates acceptance in Salesforce. And here the system should generate a contracting agreement for the contractor to sign online. So here, I'm assuming like the contractor once accepts the uh, agreement, they would update the location status to acceptable, and that would trigger an after save flow, which would create a contract object. And using Conga and DocuSign, these documents will be sent to the contractor for signing, and we'll have the DocuSign status object created, linking back to the contract. The system specialist is notified of acceptance and signature, and they do a final review and place the order for devices and materials. So here on the DocuSign status object, we will have an after save flow that would create custom notification for the system specialist so that they know about the acceptance. The order is created in Salesforce, and once it is flagged as complete, the information is sent to the ERP where sales order is created. So here we'll have a quick action that would create an order. And once the order is created, the system specialist can add the order products from the same price book, which are essentially the devices. And once the status is changed to complete on this order, it will trigger the integration I02, which basically is between Salesforce ESP and ERP. It is remote process invocation, fire and forget, as there is no immediate need to carry this. So here the order status changes. We'll have a flow that will publish a platform event. ESP would subscribe to this platform event, would decode the data and send it to the ERP where the order would get created. The order data should be viewable or accessible from within Salesforce. So that's where we want to actually use Salesforce Connect, and it would also expose the data from ERP back into Salesforce, which is represented by the ERP order, which will have an indirect lookup relationship with the order object. Number 6, the ERP system updates the order status at a point of arrival. So here, integration 03 is needed between ERP, ESP, and Salesforce. It is remote call-in as far as ESP and Salesforce is concerned. The ERP, once gets information about the point of arrival, would invoke the ESP REST API, and the ESP would then update the Salesforce order by changing its status to fulfill. The orders would be matched using some external ID, like the order number. Once the order arrives at a system specialist and contractor, they are notified by SMS and email. So here, once the integration I03 happens, the order status changes to fulfilled. And after save flow would get initiated, that would trigger an email alert, which would use a pre-configured VF email template for sending the email. At the same time, we will invoke SMS Magic API for sending the SMS to the system specialist and the contractor. I decided to use SMS Magic and not omni-channel because I did not see any need for two SMS or or some kind of like a major campaign blast that is needed. As part of this flow, the work order will also get created for the vendor to install this particular product or the systems on the customer's location, and they will be represented by this installation record type on the work order. During installation, as each device is added and it's connected online to the USD monitoring system, the system should automatically create a record in Salesforce and associate with the customer location. So for this integration, I04 needs to be used, which is between monitoring system ESB and Salesforce. It is remote call-in as far as ESB Salesforce is concerned. The monitoring system invokes the ESB REST API once it receives the message of device connectivity. And then the ESB will create an asset record in Salesforce using standard REST API, linking it to the location, which is represented by this relation between location and asset. Once the installation is final information from the installation is sent to the ERP, which results into creation of an invoice. For this integration 05, which would happen between Salesforce ESP and the ERP, and it would use remote process invocation, fire and forget. Again, there's no immediate need to send this. So this would happen once the uh, order status is marked as complete. The after save flow will get initiated, which would publish a platform event, and the ESP would then update the ERP, which would create the ERP invoice. Next, let's go into the scheduled maintenance. The maintenance schedule is set by the system specialist once the installation is complete, and it's managed by the support center after installation. Each customer location is managed twice a year. So this is represented by having a maintenance schedule object linked to a location record. And the location maintenance schedule will have like frequency, time, duration, and other parameters to aid in this particular maintenance. Scheduled maintenance is 1 week away. The service order needs to be created in the appropriate ERP. So this can be done by running an Apex patch daily, looking into the maintenance schedule, and if it's 1 week away, it would create a work order. And this would trigger an integration I06, which is between Salesforce, ESP, and the ERP. Again, it's remote process invocation, fire and forget because of no immediate action being needed. This will happen when the work order is created by the Apex batch, which would in turn generate a flow, and a platform event would get published, which ESB would subscribe to and call the ERP to create a service order. Once the maintenance is complete, the system specialist updates Salesforce on their mobile device, and the status of the ERP service order is updated. So this is similar to the previous one. Only thing is it goes through the update flow. But here the main difference is we are using remote process invocation request reply, as there is a need for a real-time call. So it's an immediate call. So this would happen when the work order is updated by system specialist. This would trigger a flow, and here we can use an external service pre-configured on the ESP, which once receives that particular payload would call the ERP to create a service order update. Next, let's look into the monitoring and issue management. There are three vectors through which issues may get raised. So the first one is that the monitoring systems can make real-time API calls when certain events occur, and Salesforce needs to be updated when certain events are raised in the monitoring system. So here we need to do integration I08, which is between monitoring system and Salesforce through the ESP. This is a remote call-in as far as ESP and Salesforce is concerned. The monitoring system would invoke the ESP API once it receives some issue below a certain threshold, and that would invoke the ESB API. The ESB would then create a case directly in Salesforce, linking it to the asset. All this information would be sent by the monitoring system, which is represented here. The event should create a task associated with the issue, and a support representative then can call the customer and assess the status. So here, once a case record is created, an after save flow would create a task, and this task can be assigned to the support representatives queue, which is supported right now by Salesforce. Next, the issues raised by customer contact. Customer contacts can submit issues Again, the customer contacts can access a community. They can have a cases tab, and on the cases tab, through a quick action, they can basically create these issues which are represented by the case. So this requirement is around barcodes to identify individual devices, and those could be automatically associated by scanning with the issue. So for this is one of the reasons as well for using a hybrid app. So the hybrid app would have a JS component to scan the barcode, and the JS JavaScript backend would then create a case against the asset by interpreting the barcode's data and finding out the correct asset against which that case needs to be created. Issues submitted like this should be routed to the service reps based on geography and expertise. Again, here I propose to use omnichannel skill-based routing. Support reps are assigned certain skills and mapped to the omnichannel routing setup, and that's how the skill-based routing will happen. Next, the maintenance or repair work. If that is needed, a maintenance task gets created by the support rep, which in turn creates a service order. This ERP integration should provide immediate feedback. So this is again very similar to our integration I07. That's why I've not mentioned here. But essentially, the support reps would create a work order, and that would trigger integration I07. Lastly, we have issues created by the support reps. For customers that call the support center, issues are raised through different channels. So for this, I propose to use digital engagement chat to support the uh, chat channel as well as Service Cloud Voice. So we have the statistic around location. So this is its solution. I've captured it in our LDV side. Now let's go to the data migration needs. So the first requirement is around customer leads that need to be migrated from the CRM system for the last 5 years. So here the CRM is basically containing leads, and the leads need to be matched against the ERP to avoid duplicate data getting created in Salesforce. So I propose to use an ETL tool which would have dedupe functionality and deduplication between leads and account based on certain parameters like the name, email, or mobile. Information which is greater than 5 years would directly go to the EDW, otherwise it would go to Salesforce out here. Next, we have data from ERP system that needs to be replicated, and that data needs to be logically linked between systems. So here the main data is around accounts, contact, locations, and again the ETL tool would extract this information and use some kind of an external ID, which could be based on email, mobile, and name, to create this bidirectional connection between this information and the one which will reside in Salesforce. Last 3 years sales order and service data service order data should be created within Salesforce. So here the ERP is containing sales and service order. Again, we use some kind of external ID to map these to Salesforce. Any information greater than 3 years would directly go into the EDW. All devices from the monitoring systems needs to be replicated in Salesforce and logically linked. And some device data can exist in more than one monitoring system. So here, the monitoring system will contain these devices, which are actually assets, and those assets may have an external ID, which is in the form of a UUID, which should be used for mapping these to Salesforce assets. Again, deduplication can be done by the ETL as those exist in multiple monitoring systems. Finally, we have design documents which are residing in the specialist desktop for open orders that need to be made available in Salesforce. So as a first step, all the documents from these different desktops need to be bought into a shared network storage or network drive. I'm assuming that those documents would have the name of that customer or some identifier which uniquely identifies the customer as part of that context, which helps us to identify the record. The kill tool would then migrate this data to S3 by checking the record from Salesforce and matching it with the name of that particular file, and it will be exposed through X Files Pro. As far as the overall migration is concerned, it's a pretty standard process. We migrate from these four systems. And this is the general order: leads, accounts, contacts, devices that will follow. The data will be first going into the raw staging environment, where we do sequencing, cleaning, transforming the data, extracting it, deduping, where we looked into specific deduplications for leads, accounts, contacts, and eventually grouping it by ID. Once that is happened and it goes into the Salesforce schema, it's converted into the Salesforce schema. As far as the load is concerned, it will basically load into the lower sandboxes in smaller gradients, like 10% on Q, 25% on UAT, and full 100% load on stage. And before loading it on prod, you need to make sure that external IDs are correctly used and automations like triggers are turned off. Deferred sharing is used, and parallel mode of the bulk API is used for faster processing. Once these operations are done, we'll have to actually perform the loop and validate that everything is fine. Once everything is fine, then again deferred sharing can be enabled with parallel sharing computation for faster processing. And after that, eventually we can turn back the automation. So this is the same process we'll follow, standard data migration process. Coming to the visibility and sharing accessibility needs. So here we have the system specialist should be able to view and edit all customer and install system data for their own customers. So here I made this system specialist as owner of the account, and he's owner of most of the other objects. So that's why they'll get the data access directly. System specialist should be able to view customer and install data for other specialist customers within their local office, except for financial data. So here I propose to use ownership-based sharing to share records owned by a specialist with uh, other other specialists within the same local office. I decided not to use criteria-based sharing as we have 150 offices, and criteria-based sharing has a limit of 50. And this would not be the ownership-based sharing rule will not be used for finance because we don't want to share the finance data. All managers should be able to view and edit customer and install system data within their respective areas. So this can be met by role hierarchy. I'm assuming that the cases need not be shared because it's mostly the install data and customer information. So role hierarchy would roll up this data to local managers, regional, and HQ. Contractors should be able to view and edit data only for customer locations to which they have been assigned, except for financial data. So here we have a relationship between location and the contact, which represents the contractor. So we use a sharing set to expose this location object and also use a sharing set on the code as they need access to the code. The finance is private, hence this is not exposed to them. Here we have a need of customer contacts, which are in kind of a pseudo hierarchy linked with each other. And every primary contact on that customer account should be able to see location and subordinate information across all related accounts. So for this, I propose to use account contact relationship and basically create primary customer contacts as contacts on the other accounts. I decided not to use external account hierarchy because here the basic requirement is that every primary customer contact of an account should be able to see data belonging to the other accounts. In case of an external account hierarchy, the users on the topmost role would be able to do that, and they would also need roles. And the other problem is the internal users would lose access to those records. So that's why I decided to use account contact sharing. Support center reps should be able to see all data within their geography only, except for customer financial data. So here I assume like we can do criteria-based sharing based on the geography field, on the location, as well as on the case. And we need just 2 or 3 rules for that. Coming to the reporting needs, the support reps, system specialists, and managers should be able to run reports on sales, activity, and schedule. So I assume like we can do this using standard Salesforce reports like summary report. And we can have like dashboards defined on these objects, maintenance schedule, opportunity, and location. Support reps, which system specialists and managers should be able to run reports showing number of device monitoring events for all customers. they have access to. So for this, I propose to use Tableau CRM because we need to build reports on assets and cases which are pretty large LDVs and they would get archived off eventually. So TCRM is used here. Managers should be able to do ad hoc trend reporting on various parameters. So again, I propose to use Tableau CRM because there's a complex compute operation involved, and again, cases and assets which need to be archived because those are LDVs. Customer contacts should be able to run reports for showing issues and their status for all issues they have access to. So this can be supported using a simple list view in the community. And finally, we have a need for the public website to run live reports. So this can be done using a JavaScript and ESB. The JS will have some kind of a reporting package and would make AJAX calls to the ESB. We'll have a set timeout implementation on the JavaScript side to basically run this in a live format. Coming to the project and development requirements, the solution needs support for both English and French languages. So this can be done using multi-language, enabling multi-language, using translation workbench, custom labels, visual force templates to support these specific needs. UST has geographically separate teams for the two ERPs and three monitoring systems. ERP teams operate with a great deal of autonomy. So this can create a potential delivery risk and communication gap. So for this, the COE needs to step in and evangelize the standards across the teams. They need to set up a daily cadence or weekly cadence between the teams, have scrum of scrums for better collaboration. The IT teams have access to only one development and test environment for their respective systems. So here we have to ensure that mocks and stubs based integration is done or a contract first development is followed. Once that is done for higher environments like stage UAT, the actual integration can be done with the limited requirements. The sales management team at UST would like to have simultaneous releases for the completed solution to production in all the regions within 4 months. So here we need to make sure that there is a minimal viable product requirement setup. The PMO and change control board must step in to prevent scope creep once this MVP is set up. And a Moscow framework is used, should have prioritization so that requirements are not changed at the last moment. UST would like recommendations on how to manage the project to address project priorities, design issues, and organizational issues. Again, we can use this framework, which allows us to do backlog prioritization in a much more structured manner, the Moscow framework. And RACI can be used. Sorry, what is S? RACI to indicate who is responsible and accountable for the different project needs. The architect review board can set up the technical standards, guidance, and the roadmap. And the COE should ensure that there is proper adoption of the standards which are set up. And through this, we can mitigate the risk associated with it. With this, I come to the conclusion of my presentation. Thank you for providing me the opportunity to give this presentation.